Hello wonderful person, this is Anton, and in this video we're going to be discussing some of the new discoveries coming from Antarctica, one of the most isolated places on Earth. But specifically, we're going to be discussing something found deep inside the ice in Antarctica, because in this case, by tracing certain elements inside the ice in Antarctica, scientists were able to trace back thousands of years of the history of the solar system and basically learn something else about the mysterious local bubble we seem to be traveling through. And so in this case, by studying what's known as stardust trapped in the snow, scientists are now beginning to map exactly where the solar system is traveling through and what kind of an environment we're currently finding ourselves in. And the results are, once again, just a little bit surprising. But in order to understand exactly what this study is about and exactly what scientists are studying here, we first briefly have to discuss a very specific atom known as iron-60, which is actually surprisingly rare on planet Earth. And that's because most of the iron known to us is actually pretty stable. And so finding something like iron-60, which is a radioactive isotope, normally suggests something very powerful and something unusual in order for this to be produced. And while most of the time it was actually believed to be a kind of a fingerprint for typical supernova, the violent explosions of massive stars at the end of their lifetimes. And that's because when stars explode, they normally forge a lot of heavy elements inside of them, and then blast all of them into outer space during the explosion itself. And so essentially a lot of this ends up as interstellar dust. But because iron-60 is radioactive, it also has a half-life of approximately 2.6 million years. Which means that if we find this on Earth, it must have been produced by something else and must have been carried here by interstellar dust. As a matter of fact, approximately 2 decades ago, ESA even released this map, essentially showing us traces of iron-60 across the night skies. And so here, by using the Compton Observatory and by observing certain types of gamma rays, researchers could find out where these ancient supernova might have happened in the past. But once again, if we do find this on Earth, it means that within the last few millions of years, there must have been some kind of a supernova happening in the region. And while for a very long time we've known that Earth received these large showers of iron-60 millions of years ago. We've actually discussed some of these propositions in some of the previous videos in the description, but in essence, scientists now believe nearby supernova must have happened approximately 6 million years ago and possibly 3 million years ago. Although in this case, when I say nearby, we're talking about supernova within approximately a few hundred light years, not actually close enough to cause some kind of an extinction event. But in the last few years, there's also been a bit of a surprise. Recent studies, especially the one in 2019, started to also discover iron-60 in much more recent deposits. And specifically in 2019, scientists discovered iron-60 inside relatively recent Antarctic snow that was less than 20 years old. Which was of course a major surprise because we don't really know of any nearby supernova in the last 2 decades. And this of course suggested something else and very likely an entirely different source. It basically suggested that the solar system might currently be picking up a lot of stardust as it travels through a cloud of gas and dust in outer space. And it's really all of this dust and all of these clouds that seem to contain iron-60 from very likely ancient supernova. But this recent study that was just published in 2026, the study that as always you can find in the description, has now taken this further by looking at ice samples that are even much older. And specifically, scientists have now analyzed nearly 300 kilograms of ice from the Dronin Maudland core in Antarctica. And this one specifically seems to cover the period approximately 40,000 to 81,000 years ago. So basically human prehistory. And so by using a highly sensitive technique referred to as accelerator mass spectrometry, which allows us to count individual atoms, they discovered that the amount of iron-60 falling to Earth was much lower back in the days. Or to be more exact, it was much lower 40,000 years ago compared to what it is today. And this is an incredibly important discovery because it tells us a lot about our cosmic travel, and specifically about our location in the local bubble and how the solar system seems to be traveling through the local cloud. Which I guess means that we briefly have to discuss exactly what we know about all of this and where we think the solar system seems to be right now. As a matter of fact, it tells us a lot more about what happened here millions of years ago. And so, based on what we've studied before and based on this discovery, we know that there seem to be at least two major structures inside which the Sun is located. First, there is this really massive large structure 1,000 light years across that's referred to as the local bubble. It's essentially the region of less than average density, or basically a region that's almost an empty bubble, or a kind of a cavity in space that contains the solar system pretty much in the middle. And while it's not perfectly spherical, it's often described as a kind of an egg shape, or even a kind of an hourglass, because it seems to be pretty wide above and below the galactic plane. And compared to the rest of the galaxy, it essentially has a very low density of hydrogen, approximately 10% of what we expect from the rest of the galaxy. But it also contains gas that's extremely hot compared to other regions, with both of these observations hinting that it was very likely carved out by extremely powerful supernova, something that scientists from Harvard described a few years back. And it's essentially something that happened approximately 14 million years ago, with the Sun accidentally finding itself in the middle of this bubble right now. So essentially we're almost in the center, but in some sense by accident. But interestingly, the edges of this bubble, which of course represent these shock waves formed by the supernova itself, are pushing on the interstellar gas, and as you can see in the simulation, are also creating new star-forming regions, with all of the famous regions such as the Orion Nebula basically being right at the edge of this bubble. Or just to rephrase this, because of this supernova millions of years ago, we now have new stars forming right at the edge of the bubble. And that actually includes most of the known regions, as you can see in this image. But based on previous studies, scientists also believe that it possibly was not just one supernova, because in order to create such a massive structure, anywhere from 14 to maybe 20 supernova had to have happened around the same time. In other words, this was probably created by a separate star-forming region where a lot of powerful stars exploded one after another. And that of course means that something very similar will be formed by a lot of these regions too, once the stars inside of them go supernova too, which will continue the cycle and create more bubbles around them. But that's the local bubble. And the thing is, if we were to look a little bit closer, or basically if we were to zoom in on this, we would also discover that there is another smaller structure the Sun is flying through. This is known as the local interstellar cloud, or sometimes referred to as the local Fluff, that's only 30 light years across and resides within this much larger local bubble. And in contrast, this cloud is primarily made out of hydrogen and helium and is a little bit denser than the local bubble, approximately 6 times more dense. It's also not as hot as local bubble, with the average temperature of about 6,000 Celsius, suggesting that its origin seems to be the result of something else. And well, based on this particular study, we can now pretty certainly tell that since Earth was receiving less iron-60 40 to 80,000 years ago, it means that the solar system only recently entered this local interstellar cloud and was outside of it previously. As a matter of fact, based on the analysis, researchers now believe that the solar system must have came here approximately 40 to 120,000 years ago, and is most likely going to exit this in 2 to 6,000 years in the future. Or just to rephrase this, in 2 to 6,000 years, Earth will start getting different materials on the surface coming from all of this interstellar dust. But here we also know that as the Sun travels through this dust, the Sun's magnetic field and the solar wind create a kind of a bubble referred to as heliosphere, which is essentially a kind of a shield that prevents the majority of the gas from this cloud from reaching the inner planets. With the changes in iron-60 levels recorded in this ice, essentially acting as a definitive geological record, telling us exactly how the Sun moved through this bubble and how it entered this interstellar cloud. But there's also a bit of a mystery here. If this cloud was formed directly from a recent supernova, we would actually expect to see way more iron-60 than what's currently being detected in the Antarctic ice. Which of course raises the next question. So how did this particular cloud form? We know how the local bubble formed, and a lot of simulations suggest that it was basically a bunch of supernova, but what about this formation? Well, based on this study and the results from a lot of other studies, it essentially implies that this cloud is not a piece of an exploded star. Instead, this might be something much older and involve interstellar dust that was first swept up and then compressed by a previous supernova's shockwave. Or basically this is a remnant cloud from some other explosion very long time ago that has now been shifted and moved by the pressure from ancient supernova. In other words, it suggests that we're currently traveling through some kind of a remnant shockwave produced by a supernova possibly millions of years ago. But importantly, it also confirms that a lot of this Antarctic ice is essentially like this massive cosmic archive. And so by studying the layers of this ice, we can now directly track the history of the solar system as it traveled across the galaxy for the past 2 to 3 million years. And so these tiny atoms of iron-60 are now giving us a high-resolution map of the interstellar medium and a lot of other formations around the Sun, while also confirming that we seem to be moving through a very dynamic region and through the environment that has only recently changed, with many of these local clouds and local gas forming these very complex structures that we're only now beginning to understand and beginning to map. As a matter of fact, most of these studies are from the last 5 or 6 years. None of these studies or these observations were even possible before. But this also means that future studies can analyze even more of these ice samples, looking at even older ice, and possibly discovering additional structures that we might have passed through before. And the thing is, most of these structures would be practically invisible to even the most powerful telescopes. Because here we're just talking about clouds that don't even qualify as nebula, and are extremely low in density. But I guess more importantly, these studies might also tell us what's going to happen in the future because, based on previous studies, we know that the Sun is eventually going to enter the nearby G cloud, which based on preliminary observations, might happen in the next 2000 years. This is actually the cloud that contains the Alpha Centauri system, and does seem to contain conditions, or I guess space weather, that's a little bit different from the current cloud. And exactly what happens between these clouds and how they interact or what they do to each other is of course unknown. We just know that we're traveling toward this cloud at approximately 26 kilometers per second, and based on the observations from the NASA's IBEX or Interstellar Boundary Explorer, whose main mission was to study all of this, we know that when we enter this cloud, it will potentially change the heliosphere because the density around the Sun will change as well. And so here the change might affect the size and the shape of the heliosphere, which in turn will dictate how much cosmic radiation is going to reach planet Earth. And that's of course a very important reminder that even though we think space is empty, in reality it's really not. Because our planet and the solar system are constantly interacting with remnants from a lot of ancient stars, which despite going supernova millions of years ago, still affect the planet even today. But because we don't really know much else about this, and this is something that scientists will be tackling in some of the future studies, it means that we'll come back and discuss this more in future videos. And if you want to find out more, subscribe, come back tomorrow to learn something else, support this channel on Patreon where you can find additional videos without any ads and can DM me directly, or by joining a channel membership that grants you early access. You can also support this channel by buying the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.